Hello, my name is Keshwani. This Keshwani, Keshwani. We are here because we want to learn algebra. Today is our lesson number 182. Day 182, we are in the process of solving word problems from day 101 through 200, and today is our 82nd day of solving a word problem. The problem for today is already on the blackboard. I'm going to read it to you. It says, find the two-digit number that is equal to 8 times the sum of its digits. So we have to locate a number so that if we were to take the sum of its digits, it equals the 8 times sum of the digits equals the number itself. For example, if you were to say 23, the sum of the digits for 23 is 2 plus 3, which is 5, and 8 times 5, as you can clearly see, 8 times the sum of the digits here does not equal 23. We're looking for a number where that is true. Before you continue watching this video, make sure that you've been watching these videos in proper sequence, and if you have not, I want you to go back and watch the day number 151 first before you continue watching this video, because in day 51 we learned something that's going to apply here. And what I'm talking about is knowing how to represent a two-digit number in the language of algebra. For example, if we here's a solution. Let u be the unit digit of the number. So for example, if our number was 57, then u is 7, and let t be the 10 digit. So here t is 5, in this case 57. The question is, how do we write that in the language of algebra? How do we represent this thing? We cannot just write tu. Tu in the language of algebra would mean t times u. That's not what we meant here. We're not talking about 5 times 7. Tu represents 35 if we don't put anything in between. How do we represent a two-digit number in the language of algebra? That's what we have to understand. T, as we said, is the 10 digit. So what does 57 actually mean? 57 actually means 5 times 10 plus a 7. That's what it means. And since t equals 5 in this case, it's going to be 5 times, it's going to be t times 10 plus u. That's how we write it. Or better yet, if you want to represent 57, it's going to be represented as 10t plus u, where t equals 5, because 5 times 10 is going to give you 50, and then u equals 7. Here, t equals 5 and u equals 7. That's what we're talking about here. Let u be the unit digit, and let t be the 10 digit. And if that were true, then the number that we're looking for could be represented as, since t is the 10 digit, it is 10 times t plus the u. That is our number. That's what we're looking for. We have to find the value of t and u. And we are told that this number equals, find a two-digit number that is equal to this two-digit number right here. It's equal to 8 times the sum. This equals 8 times t plus u. 8 times the sum of its digits. Sum of the digit would be, if this is t and this is u, in this case the sum of the digit will be 5 plus 7 or 12. So 8 times t plus u. So let's continue here then. 10 times t, 10t plus u equals 8 times t plus u. T plus u is the sum of the digits. Let's multiply this out. That gives you 8 times t and then 8 times u. Here we have 10t plus u. Bring all the t's on one side and all the u's on the other side. So let's subtract 8t from both sides. And let's subtract u from both sides. of the equation. We're subtracting 8t's from both sides. This is positive 8t, this is negative 8t, so they cancel out. And here we have a positive u and a negative u, and they cancel out. So on this side of the equation, what we're left with is 10t minus 8t, which gives us 2t, equals, and here we have 8u minus a u gives us 7u. Which tells us, if we were to continue further, which tells us the ratio of the 10 digit to unit digit is, ratio of 10 digit to unit digit is 7 to 2. 7 to 2. We're not quite done yet, we still haven't located a number yet. 7 to 2 is the answer. I need the room now, and I don't want to continue doing there, so I'm going to erase the question so we can pick up on the top. I didn't mean to erase that part here. Make sure that you compare this thing with day number 51. Day number 151 rather. So we know that the number that we're looking for is such that the ratio of the 10 digit to unit digit is 7 to 2. Let's put that on the top here. Ratio of 10 digit to unit digit is 7 to 2. Well, what could be the number? Well, that should be very obvious as to what the number must be, because it has to be in the ratio of 72. If it's in the ratio of 72, 7 to 2, it cannot be 3.5 to 1, because 1 is okay, you can have a unit digit of 1, but you cannot have a 10 digit of 3.5. These have to be integers. So this is not possible. It is also not possible to have the ratio of 14 to 4. Again, you can have a unit digit of 4, but 10 digit cannot be 14, because you see these are digits. T and U represent digits, and therefore the only values, I need the room, I need a lot of room, so as I need more room, I'm going to keep erasing. Therefore, the only values T and U can have are, how many possible values T, 10 digit and a unit digit can have? 10 of them are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. 7, 8 and 9. These are the only 10 values that T and U can have. Therefore, you cannot have a digit. How can a digit be 14? Digit has to be a digit. That's why it's called a digit. It's a single digit. 10 digit cannot be 14. 10 digit has to be anything from 0 to 9. So that rules this out. It cannot be any other. It cannot be any other ratios. This is it. If the ratio is 7 to 2, that tells us the 10 digit must be 7 and the unit digit must be 2. It must be 2. There is no other possibility. That's it. And we're going to verify that in a second. We're going to verify that by going back to our problem and see if it actually makes sense. What's the sum of the digit here? Sum of the digit here is 7 plus 2, which is 9. And the problem tells us that the sum of the digits, if you were to take that, 8 times sum of the digits equals the number itself. The problem tells us that 8 times, let's put it here, eight times the sum of the digits equals the number. And what we are claiming is that the number is 72. If that were the true, 8 times sum of the digits would be 7 plus 2, which is 9, times 8. 9 8s are 72. Voila. 8 times sum of the digits does equal 72. Therefore, the number is 72. That's what we found here. The number that we're claiming is 72, and it turns out that number 72 actually is the right answer, because 72 equals 8 times its sum of the digits, which is what the problem was asking, and therefore the answer is 72. That's it. And that's all there was. Perhaps I made it too complicated, perhaps I explained too much into too much detail, but I'd rather do that than go in a hurry and then find out that you had some trouble. Now, if you're still having trouble as to how to set it up as this part here, if this part is giving you trouble as to what I meant by how to set up a two-digit number in the language of algebra, then it is important that you understand this video, 151. Alright? I will see you tomorrow on day number 183, where we'll solve an age problem of father and son. Okay? I'll see you tomorrow. Okay, bye-bye.